Alright, in this video we're going to be talking about Big Idea 3, and what's it saying that the interactions of an object with other objects can be described by forces. Uh, then what you need to understand is that at a macroscopic level, forces can be categorized as either long range or contact forces, which is just long range and short range. Electric force results from the interaction of one object that has electric charge with another object that has electric charge. And electric forces dominate the properties of objects in our everyday experiences, and electric forces may be attractive or repulsive, depending on the charges. Now, it says that we should be able to use Coulomb's law to qualitatively and quantitatively make predictions about interactions between two electric point charges. So, let's say you have a charge and Q1 subscript. And you have the charge Q1, and you have another charge, I'm going to name it Q2, and you have this distance, which is R. So, what this is saying is that, alright, you have plus and plus. These are that's gonna go this way, and that's gonna go this way. You have minus, and you have minus, that's also going to go that way, and that way. And then you have a plus and a minus. So this is just going to go towards each other. Like that. Now, basically Coulomb's law is saying that the electrostatic force, I'm just going to name it F of E electrostatic is equal to for electrostatic force is directly proportional, so let's make a constant K, okay, electrostatic force, the absolute value of Q1, because for now we're just measuring magnitude, so Q1 and Q times Q2 over the distance in meters squared. Now basically what this is saying is that electrostatic force / Coulomb's law is directly proportional to how big the charge is and how far they go. So we're measuring the magnitude of this equation here. Now basically if this Q1 is a really huge number, like 100. They're never going to be that huge, but I'm just exaggerating. And this is 50, and say they move like 3 meters. This becomes 9. And then you have this constant. Well, you need to know K, right? So for the sake of this problem, we're just going to put K E is equal to 9 times 10 to negative 9. Because that's what K is. And basically, we have to know how to use this law, well, this equation here, to determine how big this attractive force is or how big the repulsive force is. And that's about it. So basically, electrostatic force is proportional to the charge, charge of one thing, I forgot it, and the charge of the other thing over the distance traveled. Second thing you need to know is that the student is able to connect the concepts of gravitational force and electric force to compare the similarities and differences between the forces. Well, let me rewrite this equation here. My bad. Okay, can I not erase? Wow, I can't erase. Wow, that's good. Alright, I'm just gonna make a new file. So you have this equation, F of E is equal to K E Q1 times Q2 over R squared. Well, connect the concepts of gravitational force. The only thing you have to connect is that, you know, the equations are very, very similar. You have G, and you have M1 times M2 2 over R squared f of G. So basically, this is just a constant G times the mass of one object, mass times the mass of another object over the distance it is being pulled. And the only difference between electrostatic force and force of gravity is that Q1 and Q2 have charges in them, so it can either be plus plus, and that they repel, minus minus and repel, and then plus minus where they attract, where this is just attract. And that's basically the learning objective for Big Idea 3.